Hi viewers. In this session, I am going to explain about the units and dimensions which is used in the fluid mechanics. So now, the everywhere in engineering, the units and dimensions are playing the vital role. So the topics I am going to cover in this, so introduction and the physical quantities, fundamental quantities, and what is the derived quantities, and what are the different systems of units, and some basic concepts of dimensions, and also the importance of the dimension analysis, and also where we are using this, how it is used in the fluids, and also the designing of machinery. So here the units and dimensions are very the fundamental thing, and it is used to measure some physical quantities. So why we are measuring this? To design the thing or analyzing or doing some experiments, the units and dimensions are very important. So first of all, what is a unit? So this is a nothing but standardized system of measurement to describe the magnitude of the dimension. So for an example, if you are measuring some length of the canal, so it may be in meter, or it may be in feet, or everything, or it may be in kilometer. Okay, so this is a magnitude. And if you are taking the dimension, so it is the property used to describe a body or system. So in terms where these dimensions can be described in quantitatively, and also it will be assigned the numerical values. So now we will see about the some different things. So the first one is, what is a physical quantity? So it is a measurable property of a system. For an example, if it is a length, mass, time, force, and pressure and velocity. So among this, the main important fundamental quantities are length, mass, and time, and temperature. Length is described by L, mass is described by M, and time is described by T. So therefore we will call that as a LMT. So the temperature will be by theta. So if I am taking that the physical what quantities, so mass, length, and thing, and if you are taking the SI units, SI unit, the mass is described by kilogram, the length is by meter, and time is by second, and the temperature by Kelvin. And what is the derived quantities? So these are all the quantities which are derived from the fundamental units. For an example, area. So area, if I am taking the area of the rectangle, it will be a length into breadth. So length is one of the fundamental thing, and breadth is also another fundamental. So if you are multiplying both the things, we will get the area of the rectangle. So similarly, we will find the area of different shapes, and the volume. So volume is nothing but, if I am taking some cube, it will be length into breadth into thickness, and the velocity, acceleration, and force. So everything which we are obtaining from the fundamental quantities. So, and we will see some units, SI units of fundamental quantities. So here the dimension, we are using velocity as L t power minus 1, acceleration L t power minus 2, the force is ml t power minus 2. So if I taking this the SI unit, it will be meter per second, the acceleration is meter per second square, the force is described by the unit. So here similarly, here these are all the some few derived units which we are going to use in the fluid mechanics course. So these are all the important property. So in next session I will explain that. So what is the different property and what are the units. So if I am taking this the systems of unit, so there are three systems of units are there. The one is the SI unit, and next one is a CGS and MKS. So here this SI units, it is the international system of units. It is the most widely used in the engineering. Okay, so this is the international. So every part of the country we are using, every part of the world we are using this system of unit. And it is based on the fundamental units. So the SI unit, I am showing some of the examples. The length we are described by meter, mass is kg, and time is second. So similarly for other derived units and also the fundamental units, the SI units are there. And the CGS units. So what is the full form of CGS units? It is nothing but centimeter, gram, and second. this length we are described by the centimeter. The mass instead of kilogram we are using the gram, and the time we are prescribing by the S, and the force is dyne, and the pressure is given as dyne per centimeter square. So and next, if I am taking MKS unit, that is um, the another thing is the MKS unit. So now we will see about the dimensions. So what is a dimension? So it is expression of the nature of the physical quantity. So we are mostly we are using the MLT. The M is mass, L is length, and T is time. And also it is independent of unit system. And the example for some dimensions or the velocity is LT per minus 1, the force MLT per minus 2. Similarly, the other dimensions. And so if you are taking that, what is the importance? So why you should know that? So here this is a very important when we are designing any machineries or in any thing. So if you want to find the correctness of the any equations, this is very, very important. And also to designing and to testing the models. So before constructing any huge structure, we will make some small models and we will test the things. So where this dimension analysis is playing very, very important role. And also this is used in the flow measurements and the pump and turbine analysis, and also in the similarity and the model analysis. So now we will summarize this thing. So in this session we have seen that what is a unit and what is the dimension, why it is important, and different systems of units, and also the we saw some of the units for basic thing, that is the fundamental units, and also we saw some examples for the derived units, and also how it is important in the fluid mechanics and also the machinery. So thank you for listening this video.